is undertaking a series of infrastructure mega projects of unprecedented scale, from record-breaking bridges and tunnels to vast renewable energy installations, as part of its strategy to peak carbon emissions by 2030 and achieve carbon neutrality by 2060. These projects not only showcase cutting-edge engineering, but also serve strategic and environmental objectives. Below, we explore several of the most significant initiatives, detailing their engineering feats, budgets, timelines, and geopolitical or environmental significance. Huajiang Grand Canyon Bridge, bridging Earth's crack. In the mountains of Guizhou Province, crews are finalizing the Huajiang Grand Canyon Bridge, soon to be the world's highest bridge, soaring 625 meters above the canyon floor. This gargantuan suspension bridge stretches nearly 3 kilometers across a chasm of the Beipen River, with a main span of 1,420 meters. Its 2 pylons tower 262 meters high, supporting steel trusses weighing 22,000 tons, about 3 times the Eiffel Tower's weight of approximately 7,300 tons. Construction began in 2022 and was completed ahead of schedule, with opening slated for June 2025. Remarkably, the entire 2.2 billion yen project, equivalent to $280 million, took only about 3 years. The bridge's impact will be transformative for this rural region by providing a direct crossing over what locals call the Earth's crack. It will slash travel time across the canyon from 70 minutes to just over 1 minute. This new link is expected to boost tourism and rural revitalization, with plans for an extreme sports park at the canyon floor. Local officials tout the bridge as a showcase of Chinese engineering prowess and a catalyst for Guizhou's goal of becoming a world-class tourist destination. With its record height and elegant span, the Huajiang Grand Canyon Bridge symbolizes China's ability to conquer formidable terrain, all while improving connectivity and economic prospects in remote areas. South-North Water Transfer replumbing a nation. China's South-North Water Transfer project is a multi-decade mega project on par with its Great Wall, but for water. A network of canals and tunnels, it channels 44.8 billion cubic meters of fresh water annually from the water-rich Yangtze River in the south to the arid north. This is the largest water diversion scheme ever attempted, with 3 major routes: an eastern route following the historic Grand Canal, a central route carrying water from the Han River to Beijing-Tianjin, and a proposed western route diverting alpine rivers toward the northwest. Construction began in 2003, and the first phases of the eastern and central lines became operational by late 2014. The scale and investment are staggering. Over 500 billion yen has been spent to date. In the past decade alone, the project delivered 76.7 billion cubic meters of water to northern cities, benefiting 185 million people in 45 cities. By alleviating chronic water shortages, it supports economic growth and curbs unsustainable groundwater pumping in the thirsty North China Plain. The central route, a 1,264-kilometer gravity-fed aqueduct from Hubei to Beijing, now provides 9.5 to 10 plus cubic kilometers per year and is being expanded. A new 55 billion yen extension will connect the Three Gorges Reservoir to the canal by 2031, boosting the route's capacity to 11.5 billion cubic meters annually. Despite its benefits, this replumbing of China faces immense challenges. Hundreds of thousands were relocated to create reservoirs, and the canals cut across seismic zones and ecosystems. Critics note environmental and social costs, but Beijing has paired the project with water conservation mandates and pollution control. Indeed, officials report improved water quality and replenished rivers in the north as clean Yangtze water flows north. The South-North Transfer is thus not only an engineering feat, with massive tunnels, pumping stations, and bridges over waterways, but also a strategic fix to China's uneven water distribution. As climate change brings more droughts to the north, this colossal project is deemed essential to weatherproof China's development. It embodies China's penchant for long-term planning. Conceived by Mao in 1952, launched in the 2000s, and still expanding with a western route to channel water to the Yellow River Basin now on the drawing board. Yarlung Mega Dam, taming the Everest of rivers. In the deep gorge of the Yarlung River in Tibet, China plans to build what would be the world's largest hydroelectric dam, a project of epic scale and ambition. Recently approved in late 2024, the Medog Hydropower Station, named for Medog County, is designed with a staggering 60,000 megawatts, that is 60 gigawatts, capacity, 3 times the output of the Three Gorges Dam. This single station would generate an estimated 300 billion kilowatt hours per year, enough to power 70 to 80 million homes. If completed, it will claim the title of world's largest hydropower facility. The dam will harness the Yarlung Changpo's Grand Canyon, the world's deepest gorge. In just 50 kilometers, the river drops over 2,000 meters in elevation. Engineers plan to tunnel through the Himalayas, boring 420-kilometer tunnels through the Namcha Barwa mountain to divert and tame this energy. The project's scale is matched by its cost. Over 1 trillion yen, approximately $137 billion, has been budgeted, making it one of the most expensive infrastructure projects in human history. Construction was authorized in December 2024 and is planned as a single-phase build targeting 2033 for commencement of operations. Beijing frames the megadam as central to its clean energy drive, a cornerstone to hit the 2030 peak emissions goal and replace coal power. Indeed, China is pouring investment into renewables, nearly $890 billion in hydro, solar, and wind in 2023 alone, and the Yarlung project would provide massive zero-carbon power to the grid. However, it is not without controversy. The dam sits in a seismically active, ecologically rich region on the Tibetan Plateau, raising concerns about landslide risks, displacement of local Tibetan communities, and impacts on downstream water flows to India and Bangladesh. Human rights and environmental groups have voiced fears that altering this wild river could devastate sacred landscapes and biodiversity. India, downstream on the Brahmaputra, the Changpo's name beyond Tibet, is warily monitoring the plans due to water security implications. Chinese state media insist the project will prioritize ecological protection and bring green development and water storage benefits to Tibet, yet much remains under wraps. Few environmental impact details have been released. The geopolitical and environmental sensitivities have led some analysts to dub this the most consequential dam project since Three Gorges. If China succeeds in building the Yarlung Changpo Dam, it will demonstrate its ability to execute engineering on a literally Himalayan scale, but the world will be watching closely to see at what cost. CR-450, the world's fastest bullet train. China already operates the globe's longest high-speed rail network. Now it is developing trains to run even faster. Enter the CR-450, a new generation of high-speed electric multiple unit EMU trains designed for a 400 km per hour operating speed and up to 450 km per hour in tests. Unveiled as prototypes in late 2024, the CR-450 represents the cutting edge of rail technology. These sleek silver bullet trains are significantly faster than the current CR-400 Fuxing trains, which top out at 350 kilometers per hour. Crucially, the CR-450 has achieved higher speed without a proportional increase in energy consumption. Engineers at CRRC, China's state rail builder, implemented a host of innovations. Permanent magnet traction motors that improve efficiency by 3% over older motors, lightweight materials, carbon fiber composites, magnesium alloys, cutting total weight by over 10%, and a redesigned nose and body to reduce aerodynamic drag by 22%. Thanks to these optimizations, an 8-car CR-450 train set uses only about 22 to 23 kilowatt hours of electricity per kilometer when cruising at 400 kilometers per hour, about the same energy per distance as its slower predecessor in People Tien. Advanced braking systems also allow it to stop from 400 kilometers per hour in 6.5 kilometers, the same braking distance as the older trains at 350 kilometers per hour in People Tien. On board, the CR-450 bristles with intelligent sensors. Over 4,000 data points are monitored in real time, and next-gen networking that improves control precision tenfold. Noise levels have been kept in check too. Despite higher speed, the cabin is about 2 decibels quieter than earlier models. Testing of the CR450 prototypes is ongoing in 2025, and China aims to deploy these trains on major corridors later this decade, targeting commercial service by 2028. At 400 kilometers per hour, a trip like Beijing-Shanghai could be done in well under 3 hours, rivaling airline speeds when factoring check-in time. The CR450 project underscores China's intent to remain the world leader in high-speed rail. Faster trains will bolster low-carbon travel, helping displace short-haul flights to cut emissions and increase the capacity of rail lines. With the CR450, China is essentially future-proofing its rail network, pushing the speed envelope while keeping efficiency and safety paramount. It's a vivid example of technological innovation dovetailing with China's carbon neutrality aspirations, since rail is largely electric and getting greener as China's grid shifts to renewables. In sum, the CR450 high-speed train is racing full throttle into the future of sustainable transport. From deep canyons to high-speed railways, China's megaprojects are just getting started. But what happens when ambition dives deep beneath the sea or rises above the skyline? In part 2, we explore the next wave of innovation, from underwater laboratories to futuristic towers and cultural landmarks. Don't miss it.